All right, here's part 2 of section 14.1, absolute extrema. Example number 2 asks us to find the locations and the values of the absolute extrema if they exist for this function. So what I'd like you to try to do is pause this video, do as much as you can, and then see how far you get. Remember, we're finding the absolute extrema. That's the very highest and the very lowest values of our function. So we're going to essentially follow a couple different steps. Remember from our last example that the first thing we did was find the derivative. Number 2 is we found the critical numbers. Remember, that's where the derivative equals 0 or doesn't exist. And then step number 3 was taking those critical numbers and evaluating them in our original, because I want to figure out how high or low they're at. But part of step number 3 is also testing the endpoints to see if they're higher or lower. So test your critical numbers and your endpoints in your original. Pause the video and see how far you get. Okay, for my derivative, I ended up getting 12x cubed minus 12x squared minus 24x. That was step number 1. Step number 2 is we're going to find our critical numbers. Critical numbers is where the derivative equals 0 or does not exist. So if I set that derivative equal to 0, it looks like I factored out a 12x, and then I factored again into an x minus 2 and an x plus 1. When I set each piece equal to 0, that's 1, 2, 3 pieces. So be careful because there's a variable out here. When I do that, I ended up getting 3 critical numbers. I got critical numbers at 0, 2, and negative 1. That's where my function, where his derivative equals 0. So that's where I possibly have those maximums or minimums, right? But who could be higher or lower than those relative maximums or minimums? Well, our endpoints. So again, step number 3 is taking those critical numbers, negative 1, 0, and 2, and plugging them into my original. We are plugging them into the original function to see where they're at. Not what my derivative is there, but where the value is at to see who's the highest and who's the lowest. So I need you to take negative 1, 0, and 2 and plug them into your original and see what you get. I ended up getting negative 3, 2, and negative 30. Now, remember, who could be higher or lower than those critical numbers? The endpoints. But this one's kind of different. This is why I gave you this example, because the question doesn't actually give you endpoints. So what we're really trying to do is find the absolute maximum and minimum of the whole entire function. Okay? So, if you remember back from college algebra, what a polynomial function looks like, if its highest degree is even, so an x to the 4th power, and the leading coefficient is positive. If it's an even exponent, the highest degree is even, then it's either going to go up, up, or it's going to go down, down. If it is a positive coefficient, like this 3 in the front, then it's going to go up, up, versus down, down. Right? So think about a parabola. If I have an x squared graph, it looks like this, where both the endpoints start by going up and end by going up if the front number, the coefficient, is positive. If the coefficient is negative, my parabola goes upside down, right? Down, down. Again, if the highest degree is even, then they're either going to both go up or both go down. If the leading coefficient is positive, they're going to go up. If the leading coefficient is negative, they're going to go down. So another thing you can kind of do is graph it. It's cheating a little bit, but it'll kind of help you visualize what's going on. So this function actually looks like this, where both of my endpoints go up, which means on this graph, we're not going to have an absolute maximum because my function is going to continue going up, 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 up. So the only thing it could possibly have is an absolute minimum. So looking at my values when I tested my critical numbers, which one of those is the very lowest value? Well, it looks like negative 30 would be my absolute minimum. That happens when x is 2. So our absolute minimum is negative 30 when x is 2, and there is no absolute maximum because my graph's going to continue going up, 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 up. They didn't give me endpoints, so I have to consider the whole picture at the same time. Hopefully that one you got as far as I did,